Hello everyone, I'm Xiaogang. Okay, next, let's look at the shared reference. We actually already used this shared reference earlier. We've used this shared reference before, right? It is very powerful, cannot be null, and it cannot reset the shared reference, such as specifying it as a null object or creating a blank reference, because it must contain a valid reference object. So unless you need it to be null, then you should use a shared reference. That is the preferred option. If there is a null case, then you need to use a shared pointer. It is not null. Not null, use a shared reference. Null, use a shared pointer. And note that it is different from C++ references. After creation, you can reassign the shared reference to another object. Then how do you initialize it? You can use MakeShared to perform a simple initialization. That is fine. In this case, it won't compile. But it seems like when we demonstrated just now in this situation, he compiled successfully as well. Very strange. We can try again later. And in this case, it says it will assert below. Yes, in this long jet, I'm not quite sure what it refers to. In the context and this part, this mutual conversion, we already covered it in the previous chapter because we know shared reference can be unconditionally and privately converted to a shared pointer, and it's best to make a judgment on the shared pointer before converting it to this shared reference. And what they compare is always the objects they point to. Whether it is the same object, rather than comparing whether these two pointers are the same. These two pointers are of course different, but the objects they point to are the same. Then they are considered equal. Okay, here we will write the live engine dataization. Okay, so here we write a function. Let's just call it myGraph. That's the simplest way. Our shared pointer. Then let's see how to declare and initialize the field. I can declare it directly like this. That's fine. Through MakeShared, there is a standard way to declare it, and then do it like this. Okay, after declaring it, let's take a look at this approach. See if it can compile. You'll find that it actually seems to compile. You see, this can be compiled. This is a bit awkward. Let's look at the second method. Let's see if it can compile. At this point, it fails to compile. You see, it can't. This controls a true form conversion, and actually this can usually be compiled. And this is usually... There's a breakpoint, right? Let's see if we can set it as a run here. Because we often have a knowledge point that is just run. Look, it's written like this inside. Let's check this empty. This should also fail to compile. Yes, look, it can't be compiled here. This run, actually, it often distinguishes itself from us, because this will ask you about this. Take a look. Here you see it used lengthy. What's the difference between it and lang PDR, right? This part is a bit magical. It can actually make this kind of specification, and actually you can assign a value to it like this. They both hold this value. Okay. Then we determine whether they are equal. If they are equal, we just print a log. Actually, we often write it like this. Yes, sometimes it will give a prompt, but tumble it one. Every time you write EF, just keep that in mind. Okay, then if they are equal, we just printed a log. For the log, we pull one from the front. We reflect it. Write that we are equal. Okay, so basically that's how you use sharing. There's no need to write this conversion for everyone because it's already been written. Okay, now let's go directly to the breakpoint. Let's check if this place just needs to print something. We'll cut the video content where we set the breakpoint here. Okay, we're at the breakpoint now. Let's just step through it. This place. Okay, very nice. So it was waiting for us here. It's waiting for us here. You can see it's stuck here now. You will notice, right? It proves that he just can't do it this way. So this place will directly crash. So we have to comment it out. Comment it out and write Runtime breakpoint crash. Okay, this just cannot compile. This place actually cannot compile either. Then we might need to find a shared runtime network. Let's just do it this way. Okay, then let's go directly to the breakpoint and see if the code below will execute normally. Wait a moment, let me write another one for you before we enter the endpoint. Let's write another inference2. Let's make it. For inference2, we'll run through it again. Then we'll make a judgment. Obviously, this inference2, it is definitely not equal, right? If inference2 is not equal to inference1, not equal to inference1, then on this side, we'll print we are not equal. Now we'll assign inference R back again. For inferencer, we'll just assign it back directly. It should be possible to do it this way. Because it can share references, it seems it can be written like this. Then let's write another condition here. If they are equal, then they are equal again. Okay, now let's go directly to the breakpoint. Directly cut off the extra content. Okay, we are now at the breakpoint. After entering, we can see that they are basically equal. Because we have an assignment here, it's fine if they are not equal here. Hey, they are equal again. So this result meets our expectations. Then we finished executing. Okay, because we created 2 objects in total, so it was destroyed twice. Then we perform a simple operation of equal, not equal, and then equal again. Alright, that's all for our shared reference. Okay, thank you everyone.